Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 21. In the given network of resistors, the 16 ohm resistor burns out as soon as it begins to dissipate 100 watt of power. What maximum voltage can be applied across terminals A and B in order to avoid the burnout of 16 ohm resistor? We have been given a network of resistors and it is given the maximum power that can be dissipated out of 16 ohm is 100 watt. So maximum voltage that can be applied through 16 ohm resistor, let it be V1. So we know P is equal to V square by R. So the voltage is V1, so it is V1 square by, and the resistor, let's call it as R1. Power is given to us as 100, so this implies that V1 is equal to P multiplied by R1 under root. P is 100, R1 value is 16, and if we take the root, 100 root is 10, and root of 16 is 4, so it will be 10 multiplied by 4, that will be equal to 40 volt. So as soon as the voltage across 16 ohm becomes 40 volt, it burns out. So we cannot give this more than that. Let's solve the system of resistors and try to convert it into one single resistor so that the rest of the voltage drop will be across that resistor only, and then we can find out the value of the maximum voltage that can be applied across AB. So here we can see that this R2 is 1 ohm, R3 is again 1 ohm, and they both are in series. They will give 2 ohm, and that 2 ohm is parallel with R4. So 2 ohm is parallel with 1 ohm. It will give 2 multiplied by 1 divided by 3. That will be 2 by 3 ohm. So in place of all the three resistors R2, R3 and R4, we can apply 2 by 3 ohm. So let me redraw the circuit. 16 ohm, and this is 1 ohm. Here we can write 2 by 3 ohm. And this 2 by 3 is in series with 1 ohm. And this is A and this is B. Now 2 by 3 in series with 1, it will be 2 by 3 plus 1 ohm, and that will be 5 by 3 ohm. So again, I can redraw the circuit, that 16 ohm, and then we are having 1 ohm here and 5 by 3 ohm and parallel to it. This is 1 ohm, and this is A and this is B. So now 5 by 3 and parallel with 1. So it will be 1 upon R equivalent is equal to 1 upon 1 plus 3 by 5. So when we solve it out, 5 and 5 plus 3 in the numerator, that is the value of 1 upon R equivalent. So R equivalent will be 5 by 8 ohm. So we will take the reciprocal of this. 5 plus 3 is 8. So now we can redraw the circuit as 16 ohm and in series with 5 by 8 ohm. So this is R2 or R-2. R1 was 16 ohm, and we need to find out the maximum voltage that we can apply across AB. Now since they are in series, the current drawn from the battery, whatever the battery that we'll be applying, it will pass through this 16 ohm as well as it will pass through 5 by 8 ohm. So we can write that I is same through R1 and R2 dash. The voltage across 16 V1, that has come out to be 40 volt, we have just obtained, and we know that V1 upon R1 is the current through 16 ohm, and let the voltage across this R2, it is V2. So that has to be equal to V2 by R2. What is the value of V1? 40. So 40 divided by 16 has to be equal to V2 divided by 5 by 8. So when we solve this out, it will be, you can solve it as 4 and 10, and then 5 and 2. So 5 by 2 multiplied by 5 by 8 has to be equal to V2. So 25 divided by 16 is equal to V2, and when you solve it, it is approximately equal to 1.56 volt. So the voltage drop across the rest of the system of resistor has to be 1.56 volt. So the total voltage that we can apply across AB, VAB, it has to be equal to V1 plus V2. V1 is the voltage drop across 16 ohm, and V2 is the voltage drop across the rest part of the system of resistors that is given to us. V1 is 40 and V2 is 1.56. So the maximum voltage that can be applied across AB, it has to be 41.56 volt, so that the resistor of 16 ohm won't burn out and it won't dissipate the 100 watt power. If you apply 42 volt, it will burn out. So we have to keep this in this limit only. That's the answer for this. Thank you. Keep learning, keep practicing, keep excelling.